I welcome you all to this session. See, in this session, we are going to learn about CNC turning operations. So, to start with, let us see some examples using blind turning and step turning operations. The first example is going to be the step turning operation. You see, this is the given workpiece. The main difference between the turning machine and milling machine, the turning operation and milling operation is, in turning operation, all workpieces are circular objects. That is, they are like a round bars. Okay, but in milling operation, the workpieces are flat. So, what is the difference if it is circular and flat? Means here the workpiece is rotating around an axis with an axis, but in milling operation the workpiece is fixed and it is flat. And second thing, the very important thing is, in milling operation, in milling machine there are three axes: x axis, y axis and z axis. These three are mutually perpendicular to each other, but in turning operation there are only two axes. That is, the z axis is always there and any one of the axis, either x or y. In this case we are going to take only x axis. Y means, here if you see, this is a circular object and this point we take it as the workpiece 0 point, that is at the axis of the workpiece. We call it as workpiece 0 point, where x is 0 and z is 0, and the axis is the direction of z direction. Say for example, I can show you by keeping my pen here. This is the z direction, so the pen is z positive and the other side is z negative. That means the z value will be positive if it is away from work surface, and the z value will be negative if it is towards the workpiece. Okay, so this is the z direction. And where is x direction? If this is x direction, and y direction will be obviously 90 degree, and this will be the y direction. Now the point to be seen here is, since this is a circular object, since the workpiece is a circular object, it keeps rotating with respect to this axis. So since it is rotating, the y axis will be rotating like this and coincides with x axis. And again same, the x axis again rotates, coincides with y axis. So x and y appears to be one axis. Okay, x and y appears to be one axis because of rotating nature of the workpiece. That is why we are considering this both x and y axis as one axis, and we are taking here that axis as x axis. So here in turning operation we have only two axes, one is z axis, other is x axis. Okay, this much is clear. Now second thing, we have to see the coordinate values. This we have marked as 0 0, that is a reference workpiece reference point, and from here the tool moves like this. This is a facing operation, and till where it is moving? It is moving till this point. At this point, what is the value of x and y? Here we should give, we should give the value of x and z, not y. Okay, so what is the value of x and z? At this point the z is 0, we know. Okay, z is 0, and the first value is for x. What is the value of x? X will be equal to the diameter of the workpiece at this plane. What is the diameter of workpiece? It is 50. So normally by seeing visually, when you are seeing, it looks like half of 50, and people will try to take this as radius value 25. No, it seems the tool is moving only 25 distance, but actually tool is moving to the periphery of the workpiece, which is at a distance of 50 mm diameter, because this 50 is not the linear distance, it is the diameter of the workpiece. That means tool is supposed to go along the periphery of the workpieces. Okay, that is why we take this value as 50, means equal to diameter. If diameter is 80, this will be 80, 0. If diameter is 90, this will be 90, 0. This is how you should give values for x in turning operation. In turning operation, when you are taking the values of x, just take the value of the diameter at that particular plane, sectional plane. Okay, so in this context, now this is 0 0, we know that, and this is diameter and z axis. Diameter is 50 at this place and z is 0 at this place. And same, if you go into this place, the diameter is again same 50 and z is 40. This is 40. but this 40 is in minus direction. As I told you, when the tool is moving towards workpiece, means inside the workpiece direction, it is negative. This is Z negative, this is Z positive. So this will be minus 40, and this will be again the diameter is 80 here, so 80 comma minus 40, and this will be 80 comma minus 60, because 40 plus 20 is 60, so totally negative Z direction, so 80 minus 60. And again here x will be 100, because the diameter is 100 here, and 80 minus 80 in Z direction, and this is 100 comma minus 100. The total Z direction is 100. 40, 20, 40 is 100. So 100 minus 100 comma minus 100. So this is the coordinate values we have found. And then now we should go for the program. Okay, going to program is something special you are going to see here in turning operation. Before going to the program, I'll just explain how the tool is moving. Say for example, the tool is here. Okay, the tool is here. Say in machine 0 point G28. You see, I have given you here G28. Tool is somewhere here. From machine 0 point, we bring the tool to this point, means near the first point, but should not touch. So it may be 50 or 51. Okay, and then just away, maybe 1, Z is 1 or Z is 2, like this. You can give it on 50, or you can give it on the before machining the workpiece is complete. It's a complete block. Okay, unmachined block. So total diameter is 100, so you can give 101 or 102. So from machine 0 point, bring the tool to 101 or 102, and Z will be plus 2, like this. So I've given you here 101, Z is plus 2. So tool will be somewhere here. After this, bring this tool to this 0, 0. Okay, after this, bring the tool to 0, 0, or bring the tool to 50, and then keep giving other values. Okay, so once it is giving, if you are bringing the tool to 50 and 0, from 101, if you are bringing this to 50 and 0, first point, and then second point is 50 minus 40, third point is 80 minus 40, fourth point is 80 minus 60, fifth point is 100 minus 80, sixth point is 100 minus 100. So this is the tool path. Tool will go like this, like this, like this, like this. This is a tool path. But at one stroke, it is difficult to make a cut like this. So tool will have to cut piece by piece, small, 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 like this. Okay, it repeats. This is called cycle. This is called turning cycle. Once if you give the coordinate points, and if you use the command called turning cycle, the command for turning cycle is G71. I have given you here G71. When you use the block called G71 block, there is two more values called as U and R. What is U? U is the depth of cut. How much depth at 101? How much depth? 1 mm depth. U1 means U is depth of cut. 1 is 1 mm depth of cut. And in 1 mm depth of cut, it completes one stroke. After finishing that, it has to come out. Come out. This is called retract. R. R value is called as retract. Retract how much? Again 1 mm up and go back. Again advance plus, because it is cycle. It says turning cycle. Again plus U one more mm and again cut. Again retract. Retract means come out. Again go back to initial. Again one more U and again cut. So this is called as turning cycle. So this command you should use. After using this command, you have to give the coordinate points. This 50, 0, 50, all these points. So tool will understand, the cutting tool will understand its path, and also the machine will understand this is a turning cycle because of G71, and machine will understand at every stroke it has to go for a depth of cut of 1, and it has to retract, means come back with 1 mm outside. Okay, so the machine operation will be completed, turning cycle operation will be completed. Now let us see how to write the program. See, first is I have written here O. This is not the block number. I have written O. 0203. What is this 0203? This 0203 is the number of program. O represents the program number. Okay. So here program number. So this you can use for all other programs also, previous programs whichever I have given you in CNC machines. To take back this program, we can take back using this program number. You can call the program from the machine later on. When you need to see this program, you can use this number and you will get the program on the screen. So this is called as program number, and rest is same. You see, block number G00, G28, home point, machine home point. Then here we have one more command called as G50 and S3000. G50 is to define maximum spindle speed. How much maximum speed a spindle can rotate, that is called G50. That spindle speed we have to define before going to the program. So always in G00, G28, then you go for G50 and spindle speed 3000 maximum. Then you select the tool M06, change tool, tool number 3. Tool number 3 is turning tool. In this case it is turning tool. Then absolute programming G00, from home point, from the machine home point we are taking to X101 Z2. From machine home point we go to X101 Z2, means somewhere here at this, you can see my pen, it comes around here. Okay, and there you give speed as spindle speed as 800. The maximum spindle speed is 3000, but the spindle speed what we are setting is 800 only. And start the spindle, start the coolant, same like before. Then we introduce the turning cycle. Turning cycle is G71, means it represents the turning cycle. You should give depth of cut is 1, R is 1, retract value means come out after cutting 1 mm depth. So U1, R1. Okay, you can give U2, R2 also, that depends. But here we are taking U1, R1. Then again G71, P600 and Q1100. What is this? Till where the cycle continues. First you say the turning cycle, G71, by giving depth of cut 1, retract value 1. Then you should tell from where the turning cycle starts till where the turning cycle continues. This is called from to value. P600 means from the block number, it is 600. From here, that means P600 means it starts, turning cycle starts from this block 600 till Q1100, means 1100. This is block number 1100 till here. So from here till here turning cycle, that is the meaning. So G71, P600, Q1100, UO, U0, W0. This is the reference in X direction and Z direction. We keep this reference as 0 because we are changing the values here. Better to keep 0. And feed value I have given 0.5. This is the feed value. Feed means how much in the direction of Z. That is called feed value. Depth of cut is U, inside, that is depth of cut. Retract means coming out is retract. Okay. So this is about the turning cycle. After giving turning cycle, we just keep giving the coordinate points. 50 Z0, 50 0, and then 50 minus 40. 50 is there, I didn't write, so just change Z value I write. Then again changing value, Z is minus 40, 80 comma minus 40, 80 comma minus 40. Then 80 is same, 80 comma minus 60, 80 comma minus 60 written here. Then again 100 comma minus 60, 100 comma minus 60. This is 100 comma minus, this is not minus 80, this is minus 60, sorry, we should change here. 100 comma minus 60, and then 100 comma minus 100, 100 comma minus 100. So we have given all the coordinate points. After giving all coordinate points, then as usual stop, we are not cutting, so G00, M05 and M, that is stop the spindle, stop the coolant, go to home point, end program. So this is about CNC turning operations. So in turning operation, the main thing is we have to we have only two axes, Z axis and X axis. Z axis is along the axis of the workpiece, and away from workpiece is Z positive, towards workpiece is Z negative. Z is in the cutting direction, Z negative is in cutting direction. And X values, if you are taking every points, the X value will be equal to the diameter of the workpiece at that plane. Okay, and that is how you should get the values. After getting values, you give the initial setting. Here two more initial settings are there. First initial setting is set the maximum spindle speed by using the code G50 and set the spindle speed as 3000, 4000, whatever. And then again you should choose the spindle speed what you need to do when you use the G90, G00 block. You can use spindle speed is 800, and then you should set this is a turning cycle of turning operations. For that you should use the command G71 and depth of cut U1 and retract value means come out value, that is R1, and then you should tell the block number for the turning cycle. For that again G0, G71 and P some number, that is a block number from where the turning cycle starts. Here it is starting from 600, so I give P600. Where the turning cycle ends, it ends at block number 1100, so I write here Q 1100, and U0, W0 is corresponding value to X and Z axis, we keep it as 0, and feed value is 0.5, and then keep giving all the coordinate points 1, 2, 3, 4, 5, 6 points. 1, 2, 3, 4, 5, 6 points. After giving these 6 points, we will tell G00 because there is no cutting. Here it is G01. Once in cutting, I write G01 because it's all a linear movement. And then after cutting finished, then you will tell G00 and M05 and N90. That is stop the spindle, stop the coolant, go to home point and M30. Okay, here just for understanding purpose I have written you what I explained you already. U means depth of cut per feed, and R means retract value means come out value. P means starting block of turning cycle, this is starting block N600 in this problem. Q means ending block of turning cycle. Here in this problem N1100 is the ending block of the turning cycle. Just for explanation purpose I have written you here. Okay, so go through this, and that's it about this step turning operations. And the next session we will see how to make taper turning operations and fillet, using fillet also. Okay, thank you so much.